And I will prove that the integral from 0 to infinity of sine t over t exists and is finite. And we are going to claim that the integral from 0 to infinity of sine t over t is equal to the limit as n tends to infinity of the integral from 0 to n pi sine t over t. Although this statement looks very intuitive, it is non-trivial because we are choosing a particular cutting point which may not guarantee that this expression will tend to the integral from 0 to infinity of sine t over t as n tends to infinity. So we are going to prove this. So we suppose that x is between n pi and n plus 1 pi. And the function of keeping x in this interval is that we can keep the sign of sine t constant. Therefore, if we compute the difference between these two integrals, we get that it is equal to the integral from n pi to x of sine t over t. Well, in this integral, the lower bound of t is n pi. Therefore, it is smaller than or equal to 1 over n pi times the absolute value of the integral from n pi to x of sine t. And we know that the integral of sine t is cosine, and therefore this integral is equal to cosine x minus sine n pi. And therefore, using the triangle inequality and the fact that cosine have an upper bound of 1, we know that it is smaller than or equal to 2 over n pi. And as n gets bigger, we know that it will tend to 0 as n tends to infinity. Therefore, we know that it is smaller than epsilon over 2 as n is bigger than or equal to n1 for some n1 which is a natural number. After that, we write the integral from 0 to n pi of sine t over t as the form of the summation from k equal to 1 up to n of the integral from k minus 1 pi to k pi of sine t over t. So let's suppose that this term here is equal to ak. Notice that the absolute value of ak is smaller than or equal to 1 over k minus 1 pi times the absolute value of the integral from k minus 1 pi up to k pi of sine t. The reason of this inequality is because the lower bound of t is equal to k minus 1 pi. And using the fact that cosine have an upper bound of 1, we know that this integral here is more than or equal to 2 over k minus 1 pi. And we know that as a tends to infinity, this expression will tend to 0. And therefore ak will converge to 0 as k tends to infinity. Also, we know that the absolute value of ak plus 1 is equal to the integral from k pi up to k plus 1 pi of sine t over t. And use the substitution that z equal to t minus pi, we know that we can transform this integral into this line, which is equal to the integral from k minus 1 pi up to k pi of sine t over t plus pi. And we know that t plus pi is greater than t. Therefore, it is smaller than or equal to the absolute value of ak. Also, we know that sine t changes sign as it lies between n pi and n minus 1 pi. So we know that an is in fact an alternating sequence. And now all the conditions for alternating series test is satisfied. And therefore, as this integral is equal to the summation of ak as k equal to 1 up to n. And therefore, by the alternating series test, we know that this integral here converges. By the definition of convergence of series, we know that there exists an n2 which is greater than n1 such that the absolute value of the integral from 0 up to n pi sine t over t minus the limit as n tends to infinity of the integral from 0 to n pi of sine t over t will be smaller than epsilon over 2 as n is greater than n2. So we guess that the absolute value of the integral from 0 to x of sine t over t minus the limit as n tends to infinity of the integral from 0 to n pi of sine t over t is smaller than or equal to the absolute value of the integral from 0 to x of sine t over t minus the integral from 0 to n pi of sine t over t plus the absolute value of the integral from 0 to n pi of sine t over t minus the limit as n tends to infinity the integral from 0 to n pi of sine t over t. This follows from the triangle inequality. And remember that this expression here is smaller than or equal to epsilon over 2 as n is greater than or equal to n2. And the second line here, it is more than epsilon over 2 as n greater than or equal to n2. This comes from the previous page, and therefore it is more than epsilon over 2 plus epsilon over 2, which is equal to epsilon as n is greater than or equal to n2. And from the definition of the convergence of a function as x tends to infinity, it means that the integral from 0 to infinity of sine t over t is indeed equal to the limit as n tends to infinity, the integral from 0 to n pi of sine t over t. And we are done with the proof that the integral from 0 to infinity of sine t over t indeed exists